Good morning, students. Today we are going to start the first lesson of chemistry, that is solid state. The basic part of solid state is differentiate between solid, liquid and gases. The question is, how does solid state differ from other two states? By using the following points, that is volume, shape, effect of temperature, effect of pressure, movement of particles and interparticle forces. Now, about solid. Solid has definite volume. Solid has definite volume. Solid has definite shape. Solid, the volume of solid change is small. Volume change is small in solid. Fourth point, effect of pressure. There is no effect of pressure on solid because solids are non-compressible. About movement of particles. Particles cannot move freely as they occupy fixed position. So that's why there is no movement of particles in solid. And in solid, the interparticle forces are strong in solid. Interparticle forces are strong in solid. Now about liquid. Liquid has definite volume. Liquid takes the shape of its container. About temperature, moderate effect on volume change. The effect of temperature, that is moderate effect on volume change, and liquids are small compressible. Now, movement of particles. Particles can move a small distance within the liquids and the intermolecular forces are less in liquid. That is, forces of attraction in liquid is less strong. Now about gas. Gas takes the volume of its container. Gas takes the volume of its container. Gas takes the shape of its container and the volume change is significantly high in gas. And gases are compressible. The particles are in continuous random motion in gas molecules and the intermolecular forces are very weak in gas. Okay. So these are the point to distinguish between solid, liquid and gases. Now next part of solid state is characteristic physical properties of crystalline solid. First point, there is a regularity and periodicity in the arrangement of constituent particles in crystalline solid. There is a regularity and periodicity in the arrangement of constituent particles in crystalline solid. The order arrangement of particles extends over a long range. That is the first characteristic of crystalline solid. Second one, crystalline solids have sharp melting points. That is, they melt at a definite temperature. That's why crystalline solids have sharp melting point. Third physical property, all crystalline substances except those having cubic structure are anisotropic. All crystalline substances except those having cubic structure are anisotropic. Anisotropic definition पुढे आहे ते मी नंतर सांगेन what is anisotropic. So सगळे crystalline solid except कोणाला सोडून those having cubic structure are anisotropic. In other words, their properties like refractive index, thermal and electrical conductivity etc. are different in different directions. These compounds are known as anisotropic. The substance whose refractive index, thermal and electrical conductivities are different in different directions are known as anisotropic. For example, ice, salts such as NaCl, metals such as sodium, gold, copper, and materials such as diamond, graphite, ceramics are examples of crystalline solids. Okay, so these are the characteristic physical properties of crystalline solid. Now, state the characteristic properties of amorphous solid. First property, The constituent particles in amorphous solids are randomly arranged. amorphous solid मध्ये जे particles असतात ते randomly arrange केलेले असतात. The particles do not have long range order. The particles do not have long range order structure, but they do have a short range order. First property is the constituent particles in amorphous solid are randomly arranged. The particles do not have long range order structure, but they do have a short range order. Second property, amorphous solids do not have sharp melting points. They melt gradually over a temperature interval. On heating, amorphous solids gradually and continuously soften and starts to flow. Okay, this is the second physical property. Third one, these solids are isotropic. What is isotropic? Isotropic means isotropic. They melt gradually over a temperature. Amorphous solid. These solids are isotropic, that is, their properties such as refractive index, conductivity are all independent of direction of measurement. They exhibit the same magnitude for any property in every direction. For example, amorphous solid, glass, plastic, rubber, tar, and metallic glass, that is metal metalloid alloy. Metallic glass means metal metalloid alloy are a few examples of amorphous solid. Next one, and it is the important part, that is isomorphous. Define and explain the term isomorphous. What is isomorphous? Two or more substances having the same crystal structure are called isomorphous. What is the definition of isomorphous? Two or more substances have the same crystal structure are said to be isomorphous. In these substances, the chemical composition has the same atomic ratio. या सबस्टन्समध्ये जे केमिकल कॉम्पोजिशन असतं त्या केमिकल कॉम्पोजिशनमध्ये ॲटॉमिक रेशो कसा असतो? सेम. फॉर एक्झाम्पल, first example NaF and MgO. Second example NaNO3 and CaCO3. पहिल्या एक्झाम्पलमध्ये ॲटॉमिक रेशोचा ॲटमचा रेशो काय आहे? NaF containing one atom and one cation and one anion, and magnesium oxide containing one cation and one anion. That's why the atomic ratio of NaF and MgO is 1:1. In the second example, that is NaNO3 and CaCO3. What is the atomic ratio of atoms? It contains one Na, one nitrogen and 3 oxygen. And in calcium carbonate, it contains one calcium, one carbon and 3 oxygen. So that's why atomic ratio in NaNO3 and CaCO3 is 1:1:3. Okay, so that is known as isomorphous. So in isomorphous substances, the chemical composition has the same atomic ratio. Second, polymorphous. हा सुद्धा इम्पॉर्टंट पार्ट आहे. डेफिनेशन इम्पॉर्टंट आहे, एक्झाम्पल सुद्धा इम्पॉर्टंट आहे. व्हॉट इज पॉलीमॉर्फस? डिफाइन अँड एक्सप्लेन द टर्म पॉलीमॉर्फस. डेफिनेशन, अ सिंगल सबस्टन्स that exist in two or more forms of crystalline structures. A single substance that exists in two or more forms of crystalline structures is said to be polymorphous. Polymorphs of a substance are formed under different conditions. Polymorphous substances कसे तयार होतात? डिफरंट कंडिशनला. फॉर एक्झाम्पल, कॅल्साइट अँड ॲर्गोनाइट आर टू फॉर्म्स ऑफ कॅल्शियम कार्बोनेट. कॅल्शियम कार्बोनेटचे दोन फॉर्म्स आहेत, एक आहे कॅल्साइट आणि दुसरा आहे ॲर्गोनाइट. त्यानंतर सिलिकाचे 3 पार्ट आहेत बघा, अल्फा कॉर्ड्स, बीटा कॉर्ड्स अँड क्रिस्टोबालाइट are the 3 forms of silica and they are polymorphous. त्यामुळे हे दोघे कोण? सिलिका अँड कॅल्शियम कार्बोनेट, हे दोघे काय आहेत? पॉलीमॉर्फस. व्हॉट इज पॉलीमॉर्फस? अ सिंगल सबस्टन्स दॅट एक्झिस्ट इन 2 or more forms or crystalline structure is said to be polymorphous. For example, calcium, the 2 forms of calcium carbonate is calcite and argonite, and the 3 forms of silica is alpha chords, beta chords and cristobalite. Okay, next part, what is meant by allotropy? allotropy आपण 11th स्टँडर्डला पाहिलेलं आहे. कुठल्या लेसनमध्ये? एलिमेंट्स ऑफ ग्रुप 13, 14, 15. बरोबर आहे? 13, 14, 15. दॅट इज एलोट्रॉपीज ऑफ कार्बन, एलोट्रॉपीज ऑफ फॉस्फरस. हे टर्म्स आपण 11th स्टँडर्डला पाहिलेले आहेत. नाव हिअर, व्हॉट इज द डेफिनेशन ऑफ एलोट्रॉपी? व्हॉट इज मीन बाय द टर्म एलोट्रॉपी? पॉलिमॉर्फिझम ऑकरिंग इन एलिमेंट्स. पॉलिमॉर्फिझमची डेफिनेशन आत्ताच पाहिली आपण. पॉलिमॉर्फिझम ऑकरिंग इन एलिमेंट्स इज कॉल्ड एलोट्रॉपी. That is known as allotropy. Example, diamond, graphite and fullerene are allotropic forms of carbon. Okay, that is allotropy. Next one, classification of crystalline solids. पुढचा पार्ट इम्पॉर्टंट आहे, क्लासिफिकेशन ऑफ क्रिस्टलाइन सॉलिड. क्रिस्टलाइन सॉलिड्स आर क्लासिफाईड इंटू 4 कॅटेगरीज. क्रिस्टलाइन सॉलिडचं क्लासिफिकेशन 4 कॅटेगरीमध्ये होतं. फर्स्ट वन आयोनिक सॉलिड, सेकंड वन covalent network solids, third one molecular solids, and fourth one metallic solid. These are the 4 crystalline forms of classification of crystalline solid. Crystalline solids are classified into 4 categories. पहिला आहे ionic solid, दूसरा आहे covalent network solid, तीसरा आहे molecular solid and चौथा आहे metallic solids. Okay, this is today's part. याचा पुढचा पार्ट आपण उद्या बघूया. थँक्यू.